So I'm Paul Breffett, the data and analytics architect at Devon Energy, and I am surprised by the number of folks that made it until almost 6 o'clock now. So I don't know. Congratulations to you, I suppose. So a little bit about Devon Energy. So Devon is a leading independent oil and natural gas E&P company. So we're an upstream oil and gas company, basically. We're headquartered in Oklahoma City, so that's where I'm from. We have about 2,800 employees, $14 billion market cap as of the time I captured this, right? And we produce about 500,000 barrels of oil equivalent a day. About our business context, right? As a producer of unconventional oil and gas reserves, we face a lot of technical and business challenges, right? So our wells can be up to 12,000 feet long horizontally, right? So we drill way under the earth and then way over, and we try to keep it within a specific pay zone. The oil and gas industry is obviously under a lot of pressure to be cost efficient, and so it kind of leads to the question of how can we maintain our technical excellence, ramp up activity while controlling our costs, right? And so in the technology organization, we've tried to bring some solutions to bear and really think differently about the way that we develop and deliver application integrations and our data warehousing landscape, right? And so historically, our integration landscape has been a bunch of point-to-point ETLs, right? We've taken data out of one system, transformed it, shoved it in another system, and it's an everything-to-everything kind of mesh, right? This web of connections. And so the mesh makes it difficult to upgrade in applications. Integrations are difficult to regression test, and data flows across the environment are arbitrarily complex and slow. And so we'll get feedback from one of the, we're deploying a new G&G application, right, to some of our users, and we get feedback like, hey, I updated this data element in this application 3 days to show up in my application, right? And well, that's just because one thing connected to a thing, that connected to a thing, that connected to a thing, and they're all overnight, right? And so the data is really slow, and that's unacceptable for the business when they're trying to actually do a thing to generate a map, right, or a report. And so we really had to take a look at how we're managing integrations and not do it better in this way, right? But do it fundamentally differently. And so for us, that's a concept called the data hub. And the data hub is really a spoke and hub model with scale-out cloud services at the core. And we're using this to increase our agility and total cost of ownership. And so really what we're doing is we're taking it and we built this right-hand side first where we took cloud, we basically moved to the cloud services, right? And then we built bulk read data services off of that. And so that's like reimagining the warehouse first, functionally, right? So it's saying, hey, we're gonna put all our data, we're gonna put it all in cloud storage, and I'll talk about that specifically in a minute. And then say, hey, we're gonna onboard analytics, reporting use cases and basically simplify that side of the equation, right? And then the next step of our journey is simplifying that left-hand side of the equation, which is more what people would probably call microservices, right? And so building this foundation where we've got all of the slow layer of a Lambda architecture built out and unified, and now building that fast layer sort of consistently, hopefully for read-write transactions, right? And so to kind of drill into what does that mean from a technology perspective, like what does the solution architecture or the technology landscape look like? It's really a set of technologies, right? And so the data hub is kind of all of this and then some. And so this is that right-hand side for us mostly. And so we take a bunch of data from source systems, we replicate it with a product called Attunity, which does near real-time replication for us, like log-level database replication, into Snowflake, which is our cloud data warehouse. And so we build reporting and analytics directly off Snowflake, right? Power BI, Spotfire, custom OData services as like a data abstraction layer. That's built directly off of Snowflake today. But then to actually transform, author, master that data, that's where we use Databricks. And so we have all of the Snowflake tables registered as Databricks tables. So somebody just goes into Databricks as their sort of like front door, right? And they just start querying data and they don't have to worry about, well, how does this map in Snowflake or like managing my user credentials or anything like that, right? We've already managed all that and just registered those in the Hive Metastore functionally. And so anytime somebody does a query in Databricks, it actually pushes down to Snowflake, runs the query, and returns the results. And so the Spark driver for Snowflake is actually really good. It does a lot of optimization right there in Databricks to push down as much as it can of the actual query and filtering to Snowflake to only return the relevant results. And so we're having a lot of success with that. And then we do have Databricks linked to Azure DevOps for our code repository and our automation. So continuous integration and deployment are managed with Azure DevOps. And so that's how we do like our release management and our continuous integration specifically. And then our orchestration and monitoring for this platform is handled with Azure Data Factory, and we do our log aggregation with Azure Monitor. And so it's all connected that way, right? So we get CI/CD from DevOps, we get monitoring, alerting, aggregation out of Azure Monitor, and that all connects, and Databricks is really like the heart of the data transform and analytics landscape, right? So it's this whole ecosystem of products that allows us to kind of build these data engineering pipelines and analytics workflows with more agility, basically. So basically, we've begun replatforming our integration, our data warehouse solutions to the data hub. So this has meant we had to rapidly mature our code management, monitoring, and orchestration, right? And so we started doing this, and we started on this journey probably 2 years ago, and we were pretty ad hoc with things, right? Promotion looked pretty, lax, and we just had a bunch of developers just developing real fast, basically. And so now that we have about 25,000 tables in Snowflake that are registered in Databricks, they grow by a couple thousand a month. The data hub served, it actually was like 85 million queries, I think, last month. And we're a company of 2,800 people. So for us, that's a huge amount of our query load, right? That's massive for us. And it's been growing about 5 to 10 million a month. So I expect we'll break 100 million pretty soon. And we use the platform for data engineering, analytics, machine learning, and deep learning workloads, and must monitor and support them, right? So we took the platform and we've had to rapidly harden it, frankly, right? And move our like enterprise objects, our enterprise data objects off of a platform that honestly just wasn't meeting our scale needs onto this functionally as quickly as we could, right? And so in order to do that, we had to kind of start building out that orchestration side of it, the monitoring side of it, and the CI/CD side of it. And that's where a lot of our journey over the last couple months has been, right? And authoring data, mastering data in it. And so that speaks to the continuous deployment. So when we started, most of our solutions were not checked into some source control, were not properly promoted, and were not being monitored. And so this is where we've iterated in this cloud environment, but honestly, it was an opportunity for us to begin with, because in the past, because of the specific tools that we used for integration, there really wasn't source code management for those either, right? I mean, so they were COTS tools, they were proprietary, right? And so it's not like there's source code to actually version control, right? It was people going into an interface, right, for an ETL tool and building the flow, and then they said they liked it, and so they moved that through a promotion process. But being able to do continuous integration and deployment for our data engineering workloads is not something we actually had before. And so this has allowed us to significantly improve the consistency of our delivering data engineering workloads, basically. So we use the Azure DevOps integration specifically for Databricks to check notebooks into source control and to get repos. We actually so that works really well for one notebook today. I know Databricks gotten feedback about that, and I think they're working on it to do for more notebooks. But we actually built a custom solution, a custom notebook for bulk check-ins of large projects. So we actually wrote our own, I wrote a script basically that goes and recursively gets all the notebooks in a folder hierarchy, right, and commits that as a bulk entity into Git. Because we have some projects, some solutions with hundreds of notebooks, literally, right? And so it was very difficult for us to get that nested folder structure with lots of different modules and subfolders consistently checked in. And so we just basically built a custom solution for that today that hopefully in time will migrate to an out-of-the-box Databricks solution. But today it works fine, right? It's a good way for us to get stuff into DevOps and into Git. And then we also use custom DevOps widgets. So we've automated our release management pipeline. So we really don't want to check stuff in to Git just to make it another step in the data engineer's life, right? What we want is for you to check it in, and that's exactly how you get it through the promotion process. I mean, that's the point of CI/CD. And so today in Azure DevOps, there are not out-of-the-box widgets for that, right? If you've tried, you know that. And so we actually wrote a bunch of custom, I wrote a bunch of custom Python stuff against the Databricks API to do release management. And there was actually a Microsoft talk just earlier where it sounded like that's still the recommendation, right? But it works fine. And so once you check things in, we basically get to have automated stage gates in Azure DevOps to say, hey, did it pass integration tests? And if so, we can deploy automatically to dev or to the stage environment, depends on the solution. And then we can have approval processes and automatically push to production, right? And so it's a lot easier, and it obviously takes the human error out of our release management, right, for our solutions. And so that's been increasingly valuable for us as we've been able to help our data engineers iterate faster, basically. And then continuous integration. So this has been more interesting probably because the continuous deployment is really just like making custom scripts, right? It's a bunch of make custom Python stuff against REST API or make PowerShell stuff or whatever your developers like, right? It's more of a technical problem than it is like imagining what does integration testing mean for your data engineering workloads, right? And so our people, so we have a lot of folks, I guess maybe a little more context, we have a lot of folks that are developing solutions in this environment. I think we have 300 or 400 people permissioned for Databricks, and we probably have, I don't know, I'd say we're maybe up to like 50 pretty consistent users, maybe a little more. And so we have that's a long tail of skill set, right? Some of those people are developers, some are Java developers, so they love Scala, right? But most of them aren't. Most of them are engineers that are coming over from like MATLAB or something like that, right? And so, or they're analysts who know SQL and they're learning Python, right? And they're expanding their skill set. And so for us to think about, well, these people are making, they're making data engineering solutions, they're making data pipelines that we want to make testable. It's kind of difficult to say, well, you should modularize your code and you should put unit tests in all of your code, right? And they say, I don't even really know where to begin with that. I don't know what that means. So we've had to think about unit testing and continuous integration kind of at 2 levels, right? And so the one level is for our developers where they write good, clean, modular code that they write unit tests and integration tests right into their modules, right? And so that's that's obviously ideal for them, but then other folks, we really just need to be able to test the entire pipeline, right? And so we're never gonna get them to modularize it, we're never gonna get them to put unit tests in specific pieces of it. And so we've actually written some custom scripts that do validation. And so we just say, hey, at the end of the pipeline, here's exactly what it should look like. Here's what it does look like. Here's how the schema's drifted. Here are the specific rows, columns, and elements that don't match, right? And then we can go back and remediate that. And so we actually have a tool that goes through and basically can be the final step of an end-to-end integration pipeline that just does a full comparison on 2 data sets, right? And tells you exactly how they're different down to a row and an element level and ensures the schema is actually technically, functionally identical. And so that's been pretty useful to us to be able to have multiple kind of speeds of onboarding and ensuring consistency for the workloads that's necessary for. And so that's that last bullet right there. All right, so data science pipelines. So we are using MLflow to capture, I guess that's one word with a lowercase f, sorry, that's improper branding, isn't it? To capture run metrics and associated model artifacts. And so really it's our model repository, right? So in order to compare runs and do all the things that you want to do, right? We also use Azure ML workspaces to deploy the models as RESTful endpoints, right? So we use Databricks as our training environment. It's actually our standard environment now, and we use it pretty extensively for model generation, model creation. And we found MLflow to be pretty good, especially because it's like an actual entity, right? An experiment is an entity along with notebooks. And so that's made it much easier for people to use than something like where we logged back to a different backplane that they had to log into in a different portal, right? The integrated user experience has made it much more, I guess, intuitive for our analysts and our data scientists. But then on the other side of it, we deploy models to Azure Container Services, that's AKS, or Azure Container Instances, which are just like single Docker instances, like serverless Docker instances. And so ACIs have proven to be really good for development testing, because it's just very simple to set up, right? We don't need a Kubernetes cluster. We create it, it's instantiated, we tear it down, and it's just deleted, right? And I don't have to worry about any managing AKS instances or anything like that. And so those have been really good for like rapid prototyping. I just get a RESTful endpoint out there and I just get to start messing with it in Postman, right? To see if I'm getting what I expect. But then AKS is obviously a lot better for actual real production grade deployments because we can do auto scaling, right, within the AKS cluster. And we can also, we also have them deployed within like our own private networks, our own VNets in Azure. So we don't have to go out into the public internet, right, for our inferencing, which is nice from a security perspective, right? I'd say, and so the flow really looks like we have object storage for Azure Blob, right? So our unstructured to semi-structured data is out in Azure Blob, and it's just your Azure S3, right? But then our data warehouse, like I already showed, was Snowflake. And so we use Databricks to merge those together, right? So like one of our use cases was trying to extract key value pairs from our invoices. So all of our invoices were in Azure Blob Storage, and all the structured like labels for that was in Snowflake. So we used Databricks to do the OCR, to generate semi-structured data, match it up with the labels, right, that were in Snowflake, and then train the model. And so our pre-processing feature engineering was Databricks, and then we actually had another step after that for Databricks that was distributed deep learning for that one specifically, right? And so we used the Horovod estimator and then kind of graduated to the Horovod runner, which has been a significant improvement. And then Azure DevOps is being used, but I definitely think we have an opportunity to use it more extensively for release management for models. So like right now we do use MLflow, we capture, it's our model registry, it's our metrics management, but we still use Databricks as the control plane for deployments. So like we have reference implementations in Databricks for here's how you deploy to Azure container instances, or here's how you deploy to Azure Kubernetes service. And I think in the future, using Azure DevOps release management would probably be more ideal for us. And so I'd say that's probably an area where we will mature. And I know that there's been some investments from Microsoft in release management for that. And then we also have an opportunity to improve the telemetry capture from our models. So there are some supported things out of the box, but I think we have some maturing to do there too, right? As to like what was the input and what was the prediction, right? And then capture kind of the ground truth and estimate our accuracy over time. Right now, that's a pretty manual process, and we probably need to do more automation there. That's I think one of our bigger opportunities in this space. And so kind of on this unified platform, right, we've successfully reduced the number of tools our data engineers, analysts, and data scientists use. So we've been able to retire several tools as we've moved to this architecture. And now we're able to also move some solutions, even where we don't retire tools. We're starting to re-platform a lot of things, right, a lot of components. So like previously our data engineering and machine learning platforms were disparate. So we did a lot of our data pre-processing, a lot of our data movement, a lot of our data pipelining in one tool, right? And then our data scientists use a different tool. And so to the extent that you wanted to change one of those pieces, right, you either had a breakpoint where you say, hey, now I want to do more advanced analysis on this data set, right? Well, now you've got to either enter a different tool and or develop an entirely different skill set, right? And so as people matured through their use cases, it was a breakpoint in their workflow, right? So all of a sudden they said, now I'm hitting a brick wall in whatever tool I'm in, and I've got to completely switch my context. So that's been nice for us, is to unify those both like in one common platform set of tools, and one deeply integrated set of tools. And using AutoML in the Azure Machine Learning Python SDK and the ML runtime give us a broad spectrum of capability. And so the interesting thing is kind of providing people a sliding scale of technical acumen required plus capability, right? And so AutoML does run distributed on Databricks from the Microsoft's Python SDK. And so we can allow people to do more automation on that end, right? And then kind of develop intermediate models, maybe with something like LightGBM that's deployed and distributed, and then advanced, distributed deep learning models. And so we kind of provide an entire gradient where you still have to have the common denominator of Python, but you get to kind of walk through the requirements of your use case in one platform, right? And so we provide more. It's not just a deep learning platform or a LightGBM platform, but we have a variety of capability depending on the skill level of the user and the requirements of the use case. And then distributed model selection and tuning combined with support for sequential data. Yeah, so this is really more about the auto machine learning, but once it supported sequential data, so a lot of our data is time series or it's like depth-wise data. And so anything from an AutoML perspective that didn't support that kind of was a non-starter. It eliminated probably 95% of our use cases. Once that was supported, we got a lot more traction with that, and we're able to unlock a lot more use cases. And then support for PyTorch with Horovod and LightGBM has been very useful. So Microsoft has a library for LightGBM that attaches, works directly on Databricks clusters, and that's been easy to use and great. And then I already kind of mentioned this about the Horovod runner, but that's their distributed deep learning implementation. And so it does support PyTorch, and it supports many more flavors of TensorFlow than it used to. It used to be very restrictive, right? with the Horvath estimator, if you've ever used that, right? It was hard to do a lot of different features. You had to have one feature column and you had to decompose that. And so that was pretty difficult. And so we've been able to iterate on our deep learning models easier, I'd suppose, with this more modern, flexible implementation. And then finally, our use cases. So last year, so I talked kind of about the architecture. I talked about the two kind of dominant bits, right? The data engineering, the data analysis. But what have we been doing with it, right? And so last year, we were focused on implementation and prototyping. So like I said, this is kind of the tail end of a really a 2-year journey, right? And so in year 1, we did a lot of R&D. We did a lot of testing. Honestly, Databricks wasn't even on Azure at that time. We're an Azure cloud company. And so we were experimenting with a lot of other alternatives, right, and having mixed success. And then last year, we landed the technologies that I showed in that reference map and focused on implementation. And so really, in the last several months, we've been rapidly expanding use cases, onboarding data, and getting rapid adoption of the platform, with many of our core data services being hosted out of it. So the hub has been used to populate our new integrated geoscience suite. And so I already alluded to it, but we were rolling out a new geoscience suite to a lot of our petrotechnical professionals. And so we're actually populating data out of the data hub, out of this architecture, directly into that application, right? And so what's been nice about that is in the past, it would have taken us several months to go into our ETL tool, get a developer, get them to iterate on the data loads, right? To say, we need these attributes from these things. And it was very inflexible. That was a very inflexible process, right? Very cumbersome, both technically and just procedurally. And so the fact that all the data is already here, it's refreshing in near real time. That's another big thing, right? The data is almost always up to date in this architecture. Is they've been able to just get data analysts and some engineers, as opposed to like ETL developers, to just build views of the data they need that then they just push into that application. And so the benefit not only is that we got data in there like in a couple weeks from once we'd onboarded that use case here, but also they've rapidly iterated it where the business has said, hey, I really don't like the way that this attribute, right, depth or something is showing up in my suite. Can you guys change it to this? And so those guys are really quickly able to go in and just modify the workflow, right, that generated that table, that created that load, as opposed to saying, yeah, let me update the spec, and then I got an ETL developer, and he's going to do it, and we've got to promote, you know what I mean? It's relatively inflexible on that side. And so this has been a big win. We also got many attributes. I think they said we got like 40 new attributes, so like data elements that previously we probably wouldn't have even bothered, right? Things that we can tell them about the wells in their suite. We've been able to get a lot more richness of data into that application much faster, right? It's been used by technicians to perform scenario planning. So one of the examples that's common in our industry is I'm developing a field, but I only have so much infrastructure, right? So I'm drilling wells, and those wells are going to produce, natural gas and water and oil, and so I have to have a certain amount of capacity to carry that away from the field at the rate I'm developing it, right? And so our business units have to say, well, based on the schedule of my drilling, will I have enough capacity, and what's the probability I'll just have to shut those wells down, which is a huge waste of capital for us, right? And so in the past, that was kind of cumbersome. The different business units had more or less sophisticated ways to do it that they were more or less happy with. And so this platform actually was used by one of our geotechnicians to automate some of that work, right? So he was able to no longer like go in and fiddle with Excel to provide updated things that were very time consuming. But he learned Python, he went into Databricks, he built a notebook, and he was able to modify his parameters at the top and just provide new drilling schedule scenario plan, right? With a 90% confidence, with a 10% confidence, and hey, if you want to modify your inputs, here you go, right? And continuously update that. And so the platform really allowed him in that case, and all of our other technicians, right? And anybody that wants to develop the skills to automate portions of their job to make themselves more productive, right? And so that's kind of, we make it default open both from a data side, right, where we add a data set and everybody gets access to it, but also from a user. So since this isn't user-based licensing, right, we can just add anybody that expresses interest, right? And then the platform is mastering and hosting enterprise data objects. So we have, I think, 450 or so master data objects, like what's a well, what's a worker, right, our actual reference data, right? And those have been hosted out of a vendor solution historically, but we've been a victim of our own success where we just had too much consumption of those, and we're having a difficulty with performance and stability. And we've been re-platforming those to this platform and authoring them in Databricks and hosting them out of Snowflake, which has been great. And then petrotechnical professionals are using it to collect data and build subsurface models. So I actually just talked to somebody yesterday where they were able to automate their data pre-processing to build like basin deposition models. And it took them at least a week. They had to do it all in Excel, very painful, right? And so we onboarded them here, built them a Databricks notebook to do all the pre-processing and the munging and things like that. And it saves them at least a week every time he has to build one of these models now, which has been huge. And then finally, one of them, we've been working with our Environment, Health, and Safety Department, our EHS department, and we have to provide greenhouse gas emissions for regulatory reporting. And the query used to take 2 days on SQL Server on a subset of the data, right? And so obviously this is a great candidate for this platform. They re-platformed it, they use all the data they want, it takes about 30 minutes, right? And of course, if that was unacceptable, we'd just give them a bigger cluster. I mean, scales linearly, right? That's the whole point. And so for us, that we've unlocked several use cases like that, where people just weren't able to access the data that we had in the way that they wanted, right? Because they didn't have the tools or the scale, right? And so the data hubs really helped us on that side. So the kind of the future for us is really more that left hand. How do we reimagine the integrations now, right? And so we've kind of done that. We started doing that with the populating our geoscience suite, but really I think over the next year we'll evolve a lot more into like how do we manage streaming data using probably Tunity, Event Hubs, Spark Streaming, Apache NiFi, those things, and build more of like a data streaming ecosystem and reimagine the way especially our geoscience applications send data to each other to make it much more real time, right, for our users. I think that's probably the first phase was more reimagining our data warehousing landscape. And now we're on the second phase of that journey right now to reimagine our data integration landscape and kind of make them the 2 layers of a Lambda architecture, right? So I think I left about 13 minutes for questions, so I can take them now or after. So. Excuse me.
So you talked a lot about technical architecture stuff in general. From a use case and user management perspective, are there any architecture constructs that you guys are using to accelerate from a development plane perspective, from the soft side, program management? Like
reference implementations or kind of like pre-built frameworks for people or?
Yeah. What we've found helps in, on that side of things is like, project plans, prerequisite, like scoping documents that are required from a use case. There's a standard business forms template that we use for use case justification.
Yeah.
We're stepping through, to make sure that, hey, business viability is there to put the right resources behind the right project to make things successful. And then there's a bunch of project management artifacts that we typically use. Are there any pieces like that you found have helped accelerate things?
So we do have some groups. There's actually somebody else from Devon here that has probably quite a bit of experience with that on the analytics side. We definitely had a lot of rigor around that where we said, hey, you've got a request for analytics, it has to have these things, and that way we lifecycle the management, like of the scope even. It's wasn't so much like a financial artifact or a project management artifact, although we have a lot of controls for that, right? Yeah. It is more of like an engagement management artifact. On our side, for the data hub like platform team, I think that we try to be more of an enabler where we say, hey, look, like we'll do the 20%, and we did the 100% on the platform, right? But we'll do the 20% on the use case, but somebody has to come with the other 80%, right? Mm-hmm. And so it's like for that scenario analysis, right? I probably did the 5% where I got them unblocked whenever there was a challenge. But honestly, somebody from that business unit had to say, this is a priority for me because this will add value to our business unit, right? Yeah. And it's honestly not my problem to prioritize at that end. We just kind of have to make sure that they're putting enough resources, and that's kind of our side of it, I guess. Okay. We do provide a lot of reference implementations, for like, hey, if I'm trying to do this, here's how I do it, right? And a lot more. And we try to continuously build like a corpus of modularized knowledge, like little videos, 5-minute kind of things, focused on empowerment, I guess, more than anything. Yeah. I hope that answered your question.
Yeah, that did. Thanks.
Yeah. Any other questions? Oh. All right. All right, well, I'll be around afterwards. Thanks, everybody. Thanks for sticking around till 6.
Thank you so much, Paul.